All right, I wanted to go over two different words. We talked about permeability a little bit, but I wanted to go over porosity and kind of give you a context for them. They're words you might hear with soil, which is why I wanted to go over them. So soil permeability is the ability of soil to drain water, okay? So if we were to pour a bunch of water into our soil, how long would it take, right? And that's an indicator of permeability. So which soil type here would have the highest permeability, would let the most stuff go through it? The gravel, right? So the gravel would have the most stuff that would be able to go through it. And so gravel would have the highest permeability. All right, sand obviously is the next, okay? We also talk about porosity, which is down here. Porosity, you guys have heard of pores, which are like, you have pores on your face, right, that get clogged with dirt, right, and form pimples. Those are pores. So porosity is a measure of how many pores are in the soil, like, and how big are those pores or those spaces. So between A and B, which one would have the highest porosity? The most pores. Which has the most spaces? A, right? A has the most spaces, so it would have the highest porosity. So if we're looking, they kind of go hand in hand, right? The soil with the biggest spaces is not going to hold very much water. The water is going to leak right through it. So sand has really big particles and has lots of big spaces, right? So it has a high porosity. It also has high permeability. They're hard words because they both start with P, right? But at least you can think porous, like pores, right? Spaces. And then permeability, permeable means stuff can go through it, okay? All right, let's review some of the stuff that we talked about in the past couple of days. So we've talked about soil horizons, right? The layers of soil. Which soil horizon is the parent material? C, okay. Which one is the topsoil? A, right? O is the one with organic matter on the very top. Okay, good. Subsoil? B, and then leaching is E, okay? Good. Sometimes you might see the word H-U-M-U-S, okay? It's different from hummus. This is hummus that you eat, okay? This is the word we're talking about, which is pronounced humus, okay? Humus. And that just means organic matter. So if you see that, just know that means organic matter. So we said organic matter is like dead leaves and grass and stuff like that, okay? Stuff from living things, all right? We also talked about the best types of soil. We said a loam is like a mixture of, what are the different types? Sand and what? Silt and clay, okay? So which is the smallest of those particles? Smallest. Clay. Clay is the smallest. Sand is the biggest. Silt is in the middle. Okay, so you need to know those. We've also talked about how soil gets degraded, right, or broken down, and basically unhealthy. So how does soil end up getting degraded? What are some of the things that can ruin our soil, basically? Okay, if we farm too much, right, because then we take the nutrients away and we don't replace them. What else can we do? Compact it, right? Smush it down. So that would reduce the porosity, right? If we're smashing our soil together, it's going to reduce the amount of pores or the amount of space in our soil, okay? What else? What can wind do? Erosion, right? It can blow all the topsoil with all the nutrients away, okay? So we talked about desertification, which is basically when the dirt turns into a desert, it gets really dry, and it loses its ability to support plant life. And this happens mostly in dry areas, okay? You're not going to get desertification in, like, the tropical rainforest as much because it typically happens in very dry areas, okay? Good. So we're going to talk today about minerals. We're just going to do like 10 minutes of notes, and then I'm going to give you time. If you didn't finish your vocab, you can finish your vocab and then work on the math review, okay? Reminder, you have the FRQ tomorrow, so I'll give you one of those tomorrow. Does anyone need a Chapter 8 FRQ? Okay. If you do and you don't remember, you can tell me later. All right. So let's go down to minerals. So when we talk about minerals, we're going to talk about how they're distributed, how different things are distributed on the planet. So plate tectonics, right, the moving of plates, the rock cycle, the formation of soil, all of those things influence where our minerals and rocks and precious gems are located. Okay, so we're talking about mining, getting valuable stuff. What did we say about the core of the earth? What is it made out of? Right, nickel and iron, okay? So the heaviest stuff is towards the center, right? Well, we don't mine iron or nickel from the core because the core is really deep down in the earth. So what we're going to talk about is what kinds of things do we mine and how do we mine them, and then what is the impact, okay? So apparently this is important for you to know because the AP exam thinks it's important to ask you what the most common element in Earth's crust is. It was on an AP exam. So if we look at the elements in Earth's crust, okay, 46, we're on page 6 of your note packet.
Thank you.
You're welcome. So 46% of the Earth's crust is oxygen. So oxygen is the most common element in the Earth's crust. Okay, so you're writing that on the blank that says most common element in Earth's crust on page 6. The second most common element is silicon. Okay, yes, as in Silicon Valley, okay, where they use it to make all of the computer parts, and I don't even know what all they use it for. But if you notice on that list, iron is pretty far down. Only 5% of the Earth's crust is iron. The reason only 5% is because it's really heavy, and we know that all the heavy stuff always wants to go towards the middle of the Earth. So when it went towards the middle, it ended up at the core, okay? Now, if we look at metals, right, you don't see like gold on this list, okay, or diamonds, okay? Carbon isn't even on this list. So if we're mining for metals, they make up a tiny, tiny percentage of the Earth's crust. And that's why it takes so much energy to get them out of the Earth and to find them. So a mineral and an ore. I wrote these definitions down for you because I don't think you'll have to know them. I don't anticipate you having to know them. I would not really memorize them if I were you. But a mineral is just something valuable that typically has a crystalline structure. So like all those pretty little like rocks that you saw on the 2 slides ago, those are mostly minerals, like diamond and gold. Ore. People told me last hour that they heard of ore. It's in Minecraft, apparently. I have never played Minecraft, but apparently you mine for ore in Minecraft. So ore is rock that has valuable stuff in it, okay? So if you have a rock that has diamond in it or gold in it, that's considered ore, rock that contains minerals and metals. Now, anyone ever seen a mine before? Okay, so mines can look a lot of different ways. I'm going to show you this clip of this copper mine, and we're going to watch kind of what happens in this copper mine here. It's only about 2 minutes here.
Copper is the first metal that...
Copper. So they're going to talk about copper, okay?
Humans extracted from the earth. It's still at the heart of our economy today, transmitting electricity and information through vast power networks and tiny cell phones, through cars and computers. We take copper for granted, but how is it obtained? The Aitik mine, owned by Boliden AB, is located in a remote region beyond the Arctic Circle in Sweden, and one of Europe's largest sources of copper. But even here, it's not easy to extract. In the Aitik mine, 1,000 kilos of earth bear only 3 kilos of the valuable metal.
So 1,000 kilograms of rock produces only 3 kilograms of copper, right? So you have to go through a lot of rock to find enough copper.
It takes a highly automated process, running through the coal, to make extraction profitable. At the mine, copper ore is unearthed by drilling and blasting. The ore is crushed and loaded onto a conveyor belt, driven by ABB motors, which carries it a full 7 kilometers through the Arctic.
That's 3 miles.
Finally, the
through
ore
the
arrives at a plant where the process of extracting copper, known as concentration, begins. At the plant, 2 huge mills built by ABB, each one as powerful as 280 cars, grind the ore to sand.
So they grind it up.
Water and chemicals are then added to extract copper from the mixture.
Doesn't that look healthy?
The entire site process is controlled by ABB systems. They've helped to double the amount of copper that can be produced from the Aitik mine every day, making Sweden's largest mine a global industry benchmark in efficiency.
So this was produced by the people that own the mine, so it's obviously kind of skewed towards them. But we're going to talk about the environmental impact, right? And so when we're looking at the chemicals, okay, they use chemicals to extract. We'll talk about what chemicals they use, but they use like sulfuric acid, which is like a really strong acid. And then like, what do you do when you're done with all this? Got to go somewhere. So that's kind of what we're going to be talking about a little bit. All right. So this is just the process, right? We mine it. Okay. We've got the metal, and we are going to separate it using chemicals, and then we'll melt it down into whatever shape we want. Okay. So it's hard to figure out how many minerals we have, because private companies often hold the rights to extract it, or it's on land that's not ours. And so if we look at how much of these different resources we have left, so global reserves here, like lead, we're going to run out of lead in 20 years. Okay? Yeah. Gold, 30 years. That's how much we have left. Okay? In the U.S., like we already, either we didn't ever have any or we already used it all up. It doesn't really matter if we run out in the U.S. because we'll just buy some from a different country. Okay? Right, but we already do a lot of that because there are only certain resources that are found in the United States. So here's a map. It's overly simplified, but like U.S., we have beryllium. We have a lot of beryllium. What do you use beryllium for? I have no idea. Okay, but we have a lot of it. Over in China, they have a ton of resources: antimony, beryllium, fluorspar, gallium, graphite. Okay, so different places of the world have different stuff. Okay, just because we want to have a lot of diamonds in the U.S. doesn't mean we do underneath our ground, right? So companies have to, or countries have to trade and sell for whatever they have or whatever they need. Yeah, gold's not on there. I don't know. You can look it up. Map of gold deposits worldwide. I mean, obviously we have some out west. Let's see here. World gold production. Gold deposits. There you go. Here, we'll put it on this. You can go gold digging. All right, so dark has the most. So you see up in Canada here, we've got some in Africa, some in Australia. Okay, light means there's some, but not as much. So U.S. doesn't have a whole ton, right? Or if, let's say, You're up here in northern Russia, you don't have any, so you gotta get it from somebody, okay? What? Yeah. Looks like Florida. Where? Here? This part? This part? This part? That's part of China. I think. Korea? I don't know. Is China down here? No, Korea? I don't know. I'm not a geography major. Don't test me on geography. India's over here. I think this is China. I don't know. Is this part of Russia? Korea? I don't know where any of this is. This is like really sad. Okay, anyways. Okay, we can have different types of mines, okay? The cool thing about these mines is they tell you exactly what they are in the title. So, strip mining, you take out strips of land and see if they have stuff in it. Now, obviously, you want to see if they have valuable stuff before you take it out, but it's a way of mining. You just cut away a strip of land, process it, use those chemicals, and then eventually you'll return this waste material, the extra rock, because remember we have a lot of extra rock, to this ginormous hole that you've dug. Do you just take strips out, strip out, take another strip out, and process it all. So the next type is open pit mining. Guess what that makes? A big open pit. I know, they were so smart when they named these, right? So, I know. Troposphere. All right, open pit. You make a big open pit or the hole in the ground. They do this a lot for that copper like we saw in the video. I don't know if you guys can tell, but there's some water down here, and it doesn't really look like a very healthy color. It's kind of green. So you'll see there are ridges. It kind of looks like they're making strips, but the difference here is they're digging a big hole in the ground. And so there's ridges on all sides. I had some other pictures here of open pit mine, and some of them are kind of crazy looking. So like this one. Anyone want to go swimming in that water? I don't. It's like green, right? Yeah, it's full of like minerals and toxic chemicals. Or like look at this like, yeah, where you can see the it's like a topographical view where you're looking down at it. Like it's a huge pit. Okay. So big pit. All right. We also have mountaintop removal. They literally blow off the entire top of a mountain. Okay. So this whole area used to be a mountain, and now it no longer is because they took dynamite and blew the mountaintop off. So you remove the top of the mountain with explosives. You'll see the word tailings. Tailings means all of the waste rock, okay? So all the waste rock is deposited. They usually deposit it down below somewhere, just because it's easy to get rid of it there. And it's harder to kind of just move it around up here. And you don't really have a hole to put it back in. Like, you could try to stack it up on top of the mountain, but it's not really going to work very well. So they just chuck the rock somewhere down at the bottom of the mountain and, hope it doesn't cause any issues. Over here, this used to be a mountaintop too. It no longer is. All right, this one you've probably heard of, called placer mining. You guys seen the gold miners, like, you know, from the old days, panning for gold. Okay, this is what that is. Okay, it's called placer mining. I believe the placer is the tool that they use. Let me Google it. So, mining in a stream bed. Oh, placer deposits. So apparently deposits in the stream are called placer deposits. So yeah, if you go out west, we went to Colorado on a family trip, and you can still like look for gold in the rivers. You don't find very much of it, but you can still find some. You could also look for like precious stones. I don't know what kind of stones, but you could look for other valuable resources in the rivers as well. And so you guys have heard of like the big gold rush, where everyone moved out west and wanted to, you know, get rich. All right, last thing. These are all surface techniques, so things you can do on the surface. You can dig a pit, dig a strip of land, you can sift through the river, blow off a mountaintop, or you guys have heard of like coal mines, right, where they're deep inside of a mountain. You could dig a tunnel, right? So this is subsurface mining. So it's below the surface of the earth. If you know that, you don't have to write that part down. Usually they dig a tunnel, a horizontal tunnel, so a sideways tunnel into the mountain. And then they drill a big, long tunnel down. A lot of times we see this for coal or diamond or gold mining. And you'll see, like, they'll have, like, little elevator type things, like really old-fashioned, and pulley systems in here. You might see, like, carts, mining carts, if you've ever seen some kind of movie or video or game that has carts in it. But everything is done underground. What might be a problem with this? Collapses, right? Okay. So we have big issues when these mines end up collapsing. And that happens frequently in developing countries or also in the olden days. So fun fact, Wisconsin is called the Badger State, not because we have a lot of badgers. We don't have a lot of badgers. Because when people from other states came to Wisconsin, there were already a lot of Wisconsinites here, and they made a living coal mining. So coal mining was really big in the southern part of our state, and the coal miners would come out of the ground, right, out of those shafts, and the people thought they looked like badgers because they were literally coming out of the ground, right, like badgers come out of the ground. So that's why it's called the Badger State. Now, coal mining, okay? If you have people in a mine here, what are some other health problems? Yeah, what they breathe in. So we actually have like something called black lung. If they breathe in all of this coal, their lungs literally get coated in black coal. So this is like human lung normal. This is one, right? And so you have to deal with a lot of inhaling, right? So if this is what happens to people that are inside of a mine, what do you think happens to people who might be, now if we have like an open mine, right, in the area around that mountaintop, right? So now if we're like, oh, hey, it's okay, we won't dig tunnels and force people to work in there. Instead, we'll just blow off the top of a mountain and it'll be great. Okay, well, the people around it are going to have to breathe in that stuff too. And that's what we'll talk about tomorrow. Yeah. Well, not black lung as much, but there are other health risks, yeah, from breathing in the stuff. Yep. All right. So here's what we're going to do. If you didn't finish your vocab, turn in your vocab, okay? And then you can work on the math review, or you can work on the FRQs and coming up with responses for that, because the FRQs are tomorrow, okay?